Hey everybody, I hope you had a good spring break. We are going to move on this week and start talking about volume. Last week or the week before spring break, what you worked on was measuring the area of parallelograms, measuring the area of triangles, and you also worked on just solid figures and what their different parts are called. You had several study jams videos that you watched, and you did some workbook pages about those things. So we are going to have a quiz this week on Thursday. So if you need to go back for a refresher just to review, it would be a good idea to check out some study jams videos underneath measurement for the area of parallelograms and triangles. And this week we're going to focus on volume. And we'll also do a review on Wednesday in a Zoom meeting if you can attend if you would like, to try to get you ready for a quiz on Thursday, okay? So for Mondays and Tuesdays assignments, you're going to actually be doing some worksheets that I've linked to talk about volume. So let's just go over what volume is, first of all, and then how to find it. And it's actually not too difficult. It's a lot like finding the area, except finding area is two-dimensional, just flat figures, and volume deals with three-dimensional figures like my box, okay? So let's look. The definition of volume is that it's a measurement that measures how many cubic units fit inside a three-dimensional object, okay? Cubic units. What are cubic units? You may never have heard that term before. Cubic units are kind of like the term that we've used for area, square units. When you find the area of a flat figure, you're actually figuring out how many squares of a certain size you can fit inside of a shape, okay? Volume is the exact same thing. You are trying to determine how many cubic units you can fit inside something that's not flat, but that's three-dimensional, like my shape. So, I have some toys in my house that will help us. This is just a wooden block, okay? It is a cube. Its three-dimensional shape is that it's a cube. It has 6 faces that are all squares, perfect squares, and those 6 faces, each one being a square, is what makes it a cube. So literally what volume measures is how many cubic units, like literal cubes, you can measure a space by seeing how many fit inside of your three-dimensional object, okay? So my box doesn't have a lid on it right now. But we have these cubes right here, and we're trying to determine how many of them you can fit inside a three-dimensional object, okay? So if I were going to measure this with cubic units, actually using these blocks, I would stack them and have them fit exactly inside of the box the very best that I could, and I'm going to try to show you how to do this. You would line them up and see lengthwise, widthwise, not only length and width-wise, but here's how I've measured it with length and width. And then those are 2 dimensions, length and width. That's how you find the area of just the bottom of the box. But then you add a 3rd dimension that you haven't used yet, and that is height. Oops, my blocks fell over, but I'll stick them back up here because you had a pretty good view of that. So this is where you would be adjusting for volume. It's the 3-dimensional measurement of a 3D figure, like this box right here. So you're literally seeing how many cubic units you could use to stack and fill this box. And the 3 dimensions are length, width, and height, how tall it is. 3 dimensions, okay? So since we're doing 3 dimensions of these measurements, we write our answer as units cubed because we're talking about cubes, so you can write the word cubed or you can use this 3. Why would we use a 3 to represent cubes? And that's because we're figuring out 3 dimensions this time. The length, the width, and the height, okay? Those are the 3 units, length, width, height. And that is of a 3-dimensional object, okay? Now, those units can be any measurement unit that you would use to measure objects or to measure space. So centimeters, inches, yards, feet, millimeters, any measurement that you can think of. Meters can be used that are used for length or distance would be used to find volume. You also could measure volume based on liquid capacity. So how many cubic liters of water you could have, or how many cubic gallons of water you could fill a space width, depending on how you wanted to measure it, okay? So, yes, that's volume. Those are the definitions of volume. Now let's look at some examples of how you would solve problems with volume, okay? So there are two ways that the formulas for volume are written. Okay, formulas are the kind of mathematical rules that you use to find certain measurements or to solve certain problems, okay? So one way to find volume is to do dimension times dimension times dimension. Those three dimensions. And what did we say the three dimensions were? Length times width times height. Length times width times height, okay? So, first of all, when we're talking about multiplying numbers, remember, you have the commutative property that says that you can multiply numbers in any order. It doesn't matter what order you decide to multiply them in, okay? So, you can do any of these numbers in any order. It doesn't matter which order you have them in, okay? So, here's the first formula. Length times width times height. The second formula is to do base, which would be the area, okay? The base of a figure is referring to its bottom face, okay? The base, that makes sense, is its bottom face. So we would actually be talking about just the flat surface that makes up the bottom of this box. So base times height. You heard that word again when we talked about the triangles, the area of triangles. And when we use base, what we're saying about base is that it's already the combination of the length times the width. So base means you've already done length times width. So sometimes you won't get 3 measurements. Sometimes you'll only get 2 measurements, and that means that you've been given the base measurement where something's already been multiplied for you. This is a 3-step multiplication. This is a 2-step multiplication because part of the work has been done for you, okay? So base times height just means you've got a built-in length times width measurement already given to you, okay? So we'll do a problem where we do it the 2 different ways to come up with your answer for volume, okay? So I'm going to start here with length times width times height. Let's say that my box has a length of 12 inches. Let's say that it has a width of 8 inches. And we'll say it has a height of 4 inches. So to solve that problem, all you have to do is multiply the 3 numbers by each other. Now, remember, associative property of multiplication says you can multiply 2 of these numbers by each other first. If you don't remember 12 times 8, then you don't have to start there. You could do 8 times 4, you know that's 32, and then multiply by the 12. You know that 12 times 4 is 48, and then you could go back and multiply that times the 8. It doesn't matter at all how you group or what order you multiply numbers in, so you really have some freedom there. So I'm going to start and simplify this a little bit. I know 8 times 4 is 32. So then I can do 32 and go back and pick up the length measurement of 12 because it does not matter what order I multiply in, okay? So 2 times 2 would be 4. 2 times 3 would be 6. Put my placeholder. 1 times 2 is 2, and 1 times 3 is 3. So I have a combined measurement, squiggled in there, of 384, okay? I'm going to erase that just so I have the space. So when I multiply 32 times 12, if you want to do that on your own, and then check it, 32 times 12 gives me 384. What? 384. Do I just write that number as my answer? It's not just going to be 384. It means that this box maybe could fit 384 cubic units inside of it in inches. Now these blocks are a little bit bigger than an inch in each direction for each dimension. So that's probably not accurate for these blocks in this box. And these may not be the true inch measurements for what this box truly measures. But just as an example, it would mean that I could fit 384 cubes inside of my box. So we need to write that in a way that expresses that we mean these cubes. So we would write 384 we would say inches cubed or cubic inches. So you would write inches to the 3rd power. Remember how we write that exponent 3 up to the top just a little bit? That's cubic units. 384 inches cubed. That would mean cubic inches, okay? All right, now let's talk about the same problem and how you would do it if you were just given the base measurement instead of a length and a width. So let's think about what the length times width would be here. If we group these together and it was already given to you as a number that you needed to use, that number that would be given to you, 12 times 8, would be 96. So they've already done part of the work for you when they give you the base, okay? And it would still be, what do we use? Inches here, okay? So 96 inches would be given to you that way. You would have a figure drawn like a cube. And if you were finding the volume of a cube like this, I know you all know the trick to drawing a cube, they would give you a height measurement, which would be 4 inches. But they'd give you just one more number like this, 96 inches. And it might be squared because that means they've already done length times width. That's 2 dimensions. So they would just put the 96 here and give you a 4. And then you just have those 2 numbers to plug in instead of the 3 numbers. And all that base means is that they've already done the length times the width for you. So it would be 96 times the 4 inches here. And if you multiply that, you should get the exact same number as the 384. So 96 4 times. And you can kind of mentally figure that in your head. 4 times 100 would be 400, and that's pretty close there, so it seems reasonable. So 4 times 6 is 24. 4 times 9 is 36, plus 2, 38 inches cubed, cubic inches. So these formulas are written 2 different ways, but they mean the exact same thing. You're just picking up here with a base. Remember, length times width tells you what the base or the bottom measurement of the cube would be, okay? So it's really simple math, just multiplying. Here you have 3 dimensions to multiply by each other. Here you've got something that's already been done with 2 dimensions for you, and then you multiply it times the 3rd dimension. So I'll move this over just a little bit so you can see it. Okay, so your first worksheet on Monday, you're going to be using just the straight formula, length times width times height. You'll be given 3 numbers. You multiply those 3 numbers, you've got your volume. Make sure you write your units correctly. Cube to the 3rd power, exponent 3. The second worksheet you're going to do on Tuesday has some of the problems where they give you 3 dimensions, but it also has several problems where you're given 2 dimensions here where the base has already been figured for you. Okay, so if you feel confused about that on Tuesday, come back to this video and check out this information here. Okay, I hope that was a good explanation of volume for you and understanding how it applies in the real world aspect, thinking about these actual cube blocks that I have and how they fit inside of the box. If you have any questions, you can certainly contact me, and we'll have a quiz on Thursday. And just to review, that quiz will be on your solid figures that we talked about week before last, in the area of parallelograms and area of triangles, and you can go back to your workbook pages on that. I think it was 133, 134, 135, something like that. Here, I can tell you actually right now. Go back and look at workbook pages 133, 133, 134, and then actually hop over, let's see, where you talked about the parallelograms. I think that came a little before it. 133, 134. Just give me a second. Yep, and then 125 and 126. Okay? And those workbook pages will be a good review for you. 133, 134, 125, 126. And then the information we talk about for volume. Okay? I hope this helps, and I hope you have a good week, and I'll see you on Wednesday if you are interested in attending the little math review for the quiz on Thursday. Okay? Have a great week. See you later. Bye.